The universe is endless, yet everything we search for keeps leading back to one thing: ourselves. Across the darkness, through dust and time, there flickers a dying ember, a small red star, faint and forgotten, hidden in the constellation of Aquarius. Astronomers call it TRAPPIST-1. It burns with the dim light of a fading coal, no larger than Jupiter. And yet, around this quiet star, something impossible took shape. 7 worlds, all rocky, all almost the same size as Earth. It's as if the universe built a mirror, not of glass, but of gravity and chance, to ask a question older than humanity itself. Can life begin twice? Most of these worlds have already fallen silent, too close, too cold, too stripped of air to breathe. But one remains, a world balanced between fire and shadow. TRAPPIST-1e. For years, it's been the whisper on every astronomer's lips, the one world that could be like home. And now, James Webb has looked deeper than any human eye ever could. 40 light-years away beyond the shimmer of red dust and dying starlight, Webb may have caught a glimpse of something extraordinary, the breath of a living world. If it's true, it would change everything. When the TRAPPIST telescopes first turned their gaze toward this faint star, no one expected anything remarkable. It was small, dim, and cold, barely burning at all, the kind of star most astronomers passed over while searching for brighter, younger suns. But in 2017, that quiet speck of light revealed a secret. As planets passed in front of it, the starlight dipped again and again in perfect rhythm. Not once, not twice, but 7 times. 7 worlds orbiting one dying ember, each one rocky, each one roughly the size of Earth. It was the first planetary system of its kind ever found, a chain of Earth-sized worlds locked in a delicate cosmic dance. To the scientists watching, it felt unreal. A single red dwarf, no larger than Jupiter, holding 7 possibilities for life. They called them TRAPPIST-1b through 1h, some close enough to their star to glow with fire, others frozen in eternal night. But one planet stood in the quiet middle ground, TRAPPIST-1e. Its orbit placed it in what astronomers call the habitable zone, where liquid water could, at least in theory, exist. It circles its star every 6.1 days, so close that one side may forever face the light while the other remains in endless darkness. To us, it looked like balance. To the universe, maybe an experiment. And when James Webb launched, this was the world that captured every astronomer's attention. If any planet around that dim red star could still hold an atmosphere, it would be this one. After its discovery, TRAPPIST-1e became an obsession. 7 planets was astonishing, but only one could sit in that fragile zone between too much light and too little. And if it had an atmosphere, even a thin one, it could change everything we know about where life can exist. But finding that out wasn't easy. The star was 40 light-years away, its glow was faint, and its planets were small, barely blocking any light as they passed. No telescope on Earth could separate their signals from the noise. So scientists waited. Then came James Webb, a machine built for questions exactly like this. When its mirrors unfolded in 2021, every piece of it, from its golden hexagons to its ultra-cold sensors, had one purpose: to read light so precisely it could see the fingerprint of a single molecule across space. Among the first to use it were a group of researchers with an ambitious name: DREAMS. They pointed Webb toward the TRAPPIST system. As TRAPPIST-1e passed in front of its star, Webb watched, measuring how the starlight changed. This is called transmission spectroscopy. When light filters through a planet's atmosphere, some wavelengths disappear, absorbed by gases like carbon dioxide, methane, or water vapor. Each molecule leaves its own pattern in the light, like a signature written across the spectrum. By decoding those patterns, Webb could tell what kind of air surrounded the planet, or if there was any air at all. It was delicate work. Each transit lasted less than an hour. Each signal was fainter than a whisper. But after 4 perfect transits, the data began to speak. And what it said surprised everyone. At first, scientists searched for what wasn't there. No trace of the light gases that young planets keep. No hydrogen, no helium. Whatever TRAPPIST-1e was born with, the star's radiation had stripped away long ago. That alone was a sign of something extraordinary. It meant the planet had changed. It had evolved. Next, they looked for carbon dioxide, the thick choking air that covers Venus. Nothing. Then for the thin ghost of an atmosphere like Mars. Still nothing. Each answer removed another possibility until only one remained, an atmosphere that could be like our own. Heavier gases, nitrogen and oxygen, mixed perhaps with traces of water or methane. Air that could hold warmth. Air that could move, carrying heat from the bright side to the dark. It wasn't proof, not yet, but it was hope. Because if such an atmosphere truly existed, it could keep the planet's oceans from freezing in the eternal night. It could make the whole world breathe. But the signals were faint, the differences subtle, almost at the edge of Webb's precision. A wrong calibration, a cosmic flare, even a heartbeat of the telescope could mimic life itself. So the Dreams team held their excitement. They ran the numbers again and again, stripping away uncertainty until only the data remained. And what they found pointed toward two possibilities. Either TRAPPIST-1e carried a thin, cold layer of air, or it had no atmosphere at all. One result would make it a frozen relic, the other, a second Earth waiting in the dark. The difference between those two worlds was hidden in a few missing photons of starlight. Imagine standing there on TRAPPIST-1e. Above you, the sky glows a deep red-orange, brighter than any sunset on Earth. The star fills the heavens, glowing enormous, more than 4 times the size of our sun in the sky. It burns dimmer, cooler, yet its light feels heavy, as if the air itself carries the pulse of its heart. Every few days, that calm is shattered. Great arcs of plasma twist into space, flares powerful enough to scorch worlds. On Earth, a storm like that would be rare, a once-in-a-century event. Here, it happens twice a week. Each burst carries energy fierce enough to strip the air from a planet, molecule by molecule, until there is nothing left to breathe. That is the curse of a red dwarf. They live for trillions of years, steady, enduring, but their youth is violent. For billions of years, they bombard their planets with radiation, long before they ever calm. If a planet cannot build and hold an atmosphere during that chaos, it may never recover. It becomes a silent world, barren, airless, cold. And yet, this same violence might also give life its spark. Those ultraviolet storms can split molecules apart, forging the chemistry that creates the first strands of RNA, the code of life itself. It is a strange paradox. The same star that could erase life may also be the one to ignite it. So the question isn't only whether TRAPPIST-1e survived its star's fury, it's whether that fury made it alive in the first place. If TRAPPIST-1e still holds on to its air, something must be protecting it. On Earth, that guardian is invisible, a magnetic field born from a molten heart of iron and nickel. It bends the solar wind, shielding us from the storms of the sun. TRAPPIST-1e might have the same defense. Its orbit is close, its movement constant, its shape stretched and released again and again by the pull of its star. That tidal flexing stirs its interior, keeping its core alive and molten. It is the same process that makes Jupiter's moon Io erupt with endless volcanoes. If TRAPPIST-1e shares that rhythm, then even under the lash of its star, its heart may still beat with heat. That warmth could fuel volcanoes, renew its surface, and keep its atmosphere from freezing away. And if that air still exists, nitrogen, carbon dioxide, maybe even traces of water, it could spread the star's heat from the day side to the night side. The bright hemisphere would not burn, the dark would not freeze. Between them, a band of perpetual twilight might circle the planet, a place where rivers could run and clouds could drift in the red glow. Astronomers call this terminator habitability, a narrow world between extremes, half fire, half shadow, yet alive in the middle. And perhaps that is where life, if it ever began here, could still hold on. Not across oceans, but within a ring of light, under a sun that never truly sets. For now, the truth about TRAPPIST-1e remains hidden in its starlight. James Webb has already seen hints, faint signatures that could be air or noise or something entirely new. Scientists will keep watching. With every orbit, every transit, every whisper of dimmed light, the picture grows clearer. And maybe soon, we'll know for certain whether that distant world has skies that breathe or silence that never ends. But even without an answer, the search itself changes us. It reminds us that life is fragile,